So for this problem, you're going to use the StatCrunch file, Apartments in Queens, New York City, Chapter 4, Classwork. And we're going to look in our class data set for it, or by searching in the data sets, and here's what it looks like. So I'm going to do that now. I'm going to go find it. So if I go into StatCrunch, rather than click Open StatCrunch, I can go to My Groups and go to our class group. And I can search for apartments. And that gets me my data. So when I click on it, it automatically opens the data set. Okay. So found the data. Let me go back, to where we were. Okay. So the data represents the square footage and monthly rent for apartments in Queens, New York City. Include a scatter plot using the square footage as the explanatory variable. So I'm going to go back to StatCrunch and draw the scatter plot. So I'm going to go to Stat Regression, Simple Linear. My X variable will be square footage. They wanted that to be the explanatory. And my Y variable will be rent. And I'll compute. Okay. Just going to make this bigger so you can see it. And when I want to get the graph, I click on the bottom right here on the arrow to go to the second page to get the graph. And I can copy this. So I right-click and copy. And then I can go back and paste it into here. Oh, this is a PDF, so I'm not going to be able to paste it, but you get the idea. Okay, so there's my graph. Oh, it's not a PDF, it worked. Okay, so next it asked me to determine the linear correlation coefficient. Stop me if I'm going too fast. So the linear correlation coefficient, I'll go back to StatCrunch. And I'll go back with the arrow. And my linear correlation coefficient is my R, right here. So 0.9686, etc. So now it asks to compare the linear correlation coefficient to the significance table to determine if the correlation is significant at the alpha equals 0.05 level. So that's way back when we were looking at the chart to look at 0.9686 on the chart. So this is a good one. This is the one that matches your book. If you go into the appendix, you can look at it. I also put a copy of it into Moodle. So if you just want to take it out of Moodle, that's fine. But we need to know our sample size. Oh, this is not a good one. I don't like this one. I like this one better. So the one on the right is the critical values for the Pearson correlation coefficient. So alpha is 0.05, and we have 0.9686, which is so high, it's not even, it's off the chart anyway. But just to do it correctly, I need to know how big my sample size is. So I'm going to go back to my data. And my sample size is 11, which I see right here. So looking here, my number is 0.602 for 11. So that's right here. Since my R is greater than 0.602, the correlation is significant. Okay, so then it asks to find the least squares regression line. This is kind of on top of it. Find the least squares regression line. So going back to StatCrunch, my least squares regression line, I don't know why it's, there we go. Can you see it now?
Yeah.
Okay. My least squares regression line is here.
Is this still question 3?
Yeah, it's a long one. So this is the equation of the line. So I can copy and paste that. Is equal to negative 399.24957 plus 2.53 times the square footage. Okay. Question E, interpret the y-intercept in this line in a sentence. So I'm going to go back to StatCrunch and look at it again. My y-intercept is where my x is equal to 0. Which means square footage is equal to 0. And that's ridiculous. Even in New York, apartments are not that small. So this is impossible, ridiculous, whatever you want to say. So the y-intercept, which is equal to negative 399.25, isn't relevant or doesn't relate to the problem. Okay, because it's impossible to have a square footage of 0. So if I go back to my homework, that's what I would write there. I would say the y-intercept is 299.45 or whatever it was. Doesn't relate to this problem. Because square footage is never 0. So it just doesn't make sense. Okay. So the next was looking at the slope. So going back to StatCrunch, my slope was 2.53. See that here? Okay. So 2.53. So the way I write this is the slope is 2.53 over 1, and that's the change in y over the change in x. And y in this case was the rent, and x was the square footage. So here we go. As the square footage increases by 1, we expect the rent to increase by $2.53. Any questions? So I write it, this equation here just helps me write the sentence.